And there we go. So what I've got for us, I've got the class Zoom over here. If you want to be part of it, great. If not, if you can see the board, great. This will be recorded. So I'm recording it as well. And let's start with this. So I've got this junction tables in SQL and SQL over here. So basically the idea is that we want to begin, and I have my zoomable table over here. So basically our notion behind this is that let's say we want to have a many-to-many. Let's say that in SQL we want to start having these many-to-many relationships, right? That's the problem that's now in front of us. So in our lab, we're going to be doing things like making playlists. And you have some unknown number of entities that are going to be in the playlist. And we want to have this playlist go out, be very long potentially. And then maybe you want to have a short playlist. Like what if you want to have one playlist that has 5 songs, another one that has 7 songs? How do you create these many-to-many associations that can accommodate the structure? Intuitively, what we have so far, when we did SQL extractions, I don't know if you remember this, but when we did a row extraction, we got arrays of dictionaries. You remember this? When you did a select statement, you basically got an array of objects. And those objects that you got had had names, key value pairs, where each name of the column basically became a key in this object that was selected out of here. So the example that I begin talking about here, the example that I use is, let's think of like a teacher in a classroom. Let's say we've got this table of teachers and we want to add students to a class. Let's say we have a class. Not every teacher has the same number of students in a class. Maybe one teacher has 31 students, maybe one has 18, maybe it's 20, 29, something like this. So the wrong way to approach this is to create a table that has teacher name, student 1, student 2, student 3, student 4, student 5, student 30, student 31. That's the wrong way. And the reason it's the wrong way is because you have to allocate all this space that could potentially be null, right? You could be allocating all these null rows for teachers that, or for students that may or may not actually be in the class. So what we kind of want to do instead is encapsulate this into some sort of structure that can hold on to it and associate these together. Ooh, that's nice. And the answer is going to be something known as junction tables. So what I've got over here in this table, I explained this in Schoology, but I'm just going to verbally explain it right now. I have 2 entity tables over here. These are going to be players and badges. And then I have this other one, player badges. So let's kind of work through this. We can tell that these guys are entity tables right now because they have primary keys. So each of these guys, every time I get a new player in my game over here, every time somebody registers for Pokemon Paul, they're going to get a new entry in this player. Ooh, that was in players. They get their name, they get their ID, they get their player. Also, I have some finite list of badges that you could potentially earn in this game. So there's a badge ID, and then there's the text associated with this badge. What we're going to have that's special today is this junction table. In this case, I'm calling it player badges. And this junction table does not have a primary key. The sole purpose of the junction table is to serve as this association point to associate table 1 with table 2. That's his whole purpose. So if we begin to look at the data of this, I've got Paul on team yellow, Archibald is on blue, James is on red, of course, and Leon is also a red. Then we have the different Pokemon, the different badges that you could have in this entity. So visit 100 Pokestops, power up Oshawott 10 times, pay to play on $100, and walk 140 miles. We could name these as whatever. So these are all the different badges that we have. Finally, I have my association table. I have my junction table over here. And in this junction table, it allows me to pair up new badge associations, right? So when player 100 gets badge 200, boom, I put a new entry inside of here. When they get badge 201, boom, put a new entry inside of here. Put a new one inside of here. And you're going to notice that it kind of feels a little bit redundant. People don't love this at first because they're like, why am I always why am I putting this thing in over? I'm putting 100 over and over again. And notice that this is completely unordered as well. So I could have 101, I could have 102, and then I'm going back to 102 over here. Like there's no real order to this thing. This is just a collection of data that allows column table 1 to be paired with table 2 over here. And the way that we would get data out of this is to, let's go, I'm going to go to my containing folder over here. I've got my SQLite viewer. So, excuse me, I've called this Pokey test. I'm going to take this database, and you can download this database, and I've got it in my viewer. So we can see here that I've got my players table. I can select my badges table, and I have my player badges. So I could say, select this from player badges, for example, where PB player equals 100. And if I execute this, I'm only going to get player 1's badges. I can use this to only select player player 102. There's player 2's badges, 102's badges. Ask me questions about this. I see some nods, but it's still a little bit weird. So what are your thoughts when you see this? Yes.
Could you repeat like kind of what the benefit of this is compared to like we doing an example of we have a teacher and student?
Yeah. So the question is, what's the benefit of using this as opposed to having a lot of columns for each individual students? So let's take this example and work with that. So let's say instead I had the badges as individuals. So I have players, and then I have like badge 1, then I would have to make a badge 1 true or false, badge 2 true, false, badge 3 true or false, etc. over here. So it's really kind of inefficient to just load up additional columns of true, false for whether or not they've received the badge or the number of badges that they've received. And then also think about it this way. What if I want to make a new badge, right? Like what if there's a special event badge that I want to create? I would have to add I would have to alter this existing table to accommodate new badges and reinitialize everybody in the database to say, hey, you are false on this new badge. Instead, what I can do is I could just have it so that they don't select off of that badge yet. I create a new badge, I can add new badges over here, and the number of badges is completely separate from the entities that could be associated with them. It's a separation tool. Great question. More questions or thoughts here? What does this remind you of? I'll put it that way. Somebody asked the question and they kind of teased this out. What sort of data structure might this feel like? Yeah, it's like a set. Yeah, feels like a set. Array being collection, something like that. It's a set. But the key thing about this is that when you look at this structure over here, you don't see set, right? Like there's nothing about this structure that says, oh my God, that's a set. But once you get more familiar with this SQL structures, you should begin to see these things where there's no primary key over here. And you're thinking, okay, like that's the case where I might use an array or like a set, something like that. This unordered list. Yeah. Great. Other things, just general housekeeping with SQL for me. I like to choose column names that are collision resistant and meaningful. So for here, for players, I have PID as my column name. I have P name. I begin all of my columns with the prefix P. That's just helpful for me, so I know what I'm talking about. Over here, for badges, I begin it with the letter B. So I can't accidentally, construct a query that uses one column name in the wrong column. Like the column names are unique to the tables, and doing prefix systems allows that to happen. Finally, I do PB player over here. Sure. Also, as general housekeeping, I like to keep the IDs for things that are like human readable. I like to keep the IDs separate from each other. So in this case, my IDs for the players are like, I'll call them 100 series, right? Like if it begins with a 10, that, or if it begins with the number 1, that is a player. So I can only have 100 players in this case. If it begins with a 2, that's a badge when I look at it. I'm not gonna, I could absolutely, there's nothing that would prevent me from restarting my badges at 100. That's totally legitimate, but I think it's easier for me to understand if I can look at these and see that they're separated by some countably infinite number over here. So maybe this would begin at 2,000, or maybe it's like 10,000 is where your badges begin. Whatever, ints are big. You can have lots of ints. If this were production grade, you would, where you're not really going to be worried about these things, you're going to use UUIDs. I don't know if you remember, we mentioned them briefly, but UUIDs are like really long strings, and that's where you could have tens of millions of these things that aren't going to collide with each other. That's the production scale version of this. That's all I want to say about junction tables. Questions, thoughts on that? Everything is just peachy. The sun is setting on us over here, and we're ready to do this. Okay, so here we go. So the question is, this is great, right? Like I've got 101, 102 over here, but I don't see what this badge actually is. And I don't see what player's name is over here. So how do I get the player's name? How do I get the player's name from here? How do I get the badge from here? Because there's nothing in this table that has that player's name. There's nothing in player badges that has that name. So the answer to how do we get these things together is, wait for it. I'm moving to the next folder over here. Inner joins. Inner joins. Okay. Has anybody used inner joins before? We have inner join aficionados in the group? No. Okay. These things are awesome. Inner joins are really good. So I have a link to my site over here that we can take a look at this. The idea, I'm giving an NFL data example over here. This data is a little bit outdated. This isn't the season that just happened. These are from 2 seasons ago. So what I've got here is I have a couple tables that I pulled together. I haven't done it because this actually took a lot of time, and I don't feel like spending time. But I'm making a table called teams. I'm trying to give collision resistant, meaningful names over here. I have a text for the primary key. And for each of these teams, I have information associated with the team. I keep information consistent with the team in its own place. If there's stuff that could possibly change or is worthy of its own sort of subfields, that's going to be in a different table. So here I go. I've got Arizona, oldest team in the league, even though they only moved to Arizona in 1995. Chicago Cardinals was where they were founded. Anyway, we get the Bills, Chargers, Rams. Anyway, so I've got some data over here, right? Founding year. And then I've got this other number, 5,000 series. This is a number that I made up. This is a me number. And this is something that I used to create our second table, which is the stadiums. So here, for each of the stadiums, I've made a table of the stadiums because the stadium could have its own sort of set of information. I want to know the year the stadium was built. I want to know the capacity. Is it a dome? What type of grass do they use? These sorts of interesting things, right? So here we go, the city and the state, right? So here, 5,001 is Acrisure Stadium in Pittsburgh, Pennsylvania, using Kentucky bluegrass, and opened in 2001. So we've got all of this information over here, and you're going to notice that these numbers, these 5,000 numbers, are identical. They look like the numbers that were in the teams, right? So those teams, when I wanted to know the stadium, I had the ID for the other table that corresponds to the stadium. So something that we might know over here, what's the, where do these Commanders play? What's that called? These are alphabetical. FedEx, okay? So 5,009, Landover, Maryland. I would expect that if I went back a page to look at the Commanders, they're using 5,009. Okay, they're playing in 5,009. All right, tearing right along. So this is the magic. This is the key. If you want to do a selection that joins these two tables together, we're going to use a command called inner join. And this is the secret sauce that is going to make that SQL lab possible for you. Okay, this is going to be the thing that makes it all possible. So here I am, I'm selecting all columns from teams. I am going to do an inner join, a new table named stadiums, but it's in the same database. So it has to be in the same database. Teams and stadiums in the same database. I'm joining this table on this column equal to this column. So where stadiums.sid was equal to teams.tstadium, where these two are equivalent, I get a join and I create a new temporary mega table that exists only in memory, only for that query. And it's really more just like a collection of pointers that gets filled out. So it's an efficient, this is why SQL is efficient in doing this kind of stuff. They have the mechanisms to do this. So here, I get columns, I get rows for each team, and I get all the columns from both tables filled out inside of here, right? Like if you'll recall that in these Washington's team over there, I only had up to 5,009, but here I now have this temporary thing where I can say 5,009 all the way down to Bermuda Grass, opened in 1997. Yes, no? So here we can begin to do more interesting operations on this guy, right? So let's take this. So if I want to say, again, this is a reason to have individualized column names, because when these two tables get joined together, all of your table names are going to be, or sorry, all of your column names are going to get like combined into this guy. So now I can say select the T name column and the S name column, which were not in the same table before, from a table named teams. It was joined to the table stadiums on this field is equal to this field. Here we go. Arizona Cardinals, State Farm Stadium. Los Angeles Chargers play at SoFi. Also, this guy at SoFi. So SoFi only had a single entry in the stadiums, but I was able to reference it twice efficiently. I don't have to redefine all the columns in SoFi Stadium. If I want to make a change to SoFi Stadium, that change applies to all the things that use SoFi Stadium because they're linked by that pivot number, right? They're linked by that number. Questions or thoughts on this one? Easy nods. Sure. Okay, great. So here we go. You can begin to do more things, right? So you can say select these columns from this table, join to another table on this stadiums on these columns is equal to this guy. Sure. So if we go back and look at this guy, select star from player badges where this guy is equal to this. I could equally say inner join something dot something where this, and you can join and get all of the fields out of this now. So these junction tables that we worked with, or that I introduced at the beginning, can be given more meaning by using inner joins back to the things that they are joining, right? So the junction tables give you the association. The inner joins allow the rest of that information to get filled out and to make sense. So what are we going to do? So I have put all of this information for you into a table called NFL.db. And I'm just going to drop this in the SQLite viewer over here. So I have 3 tables in this guy. I've got, and granted, this is wrong. This is not going to be current data. But I've got players. I've got all the players, their weight, their date of birth, their team, their position. I've got stadiums. So we can see all of our stadiums and notice that there are only 30 stadiums and 32 teams because
there are two teams, two stadiums that are shared. And then here are our teams. What I'm going to give you is a little bit of a problem over here, and we can, what do we have? 15 minutes left in class. I have 5 questions for us. I want you to solve this using inner joins. We need to get thinking in SQL. This guy, the oldest stadium in California, that one doesn't require an inner join. This is a sort ascending. But using the database, you do not need to redefine this database. You can download the database from this folder, upload it to the SQLite viewer that we had before. All the information is there. I want you to hammer out on these prompts. How do you find the largest capacity stadium in the NFC? How do you find this largest capacity stadium? So what is a query? I don't care about the answer. I care about the query that gets you there. Okay? Does that make sense? So in 15 minutes, I think we can get started. What I really want to do is I want to get our brains in this SQL mode so that tomorrow we can finish these thoughts out and really begin to go full steam ahead into the SQL lab, which will take us through next week. And then you can have some creative thoughts. So my ask for you right now is to begin working on these. Is it clear what I'm looking for you to do right now? Yeah, okay. So I'm going to stop sharing. I'm going to end the meeting.